to like a for each kind of thing. Just to go from row 1 to row whatever.
I guess don't you just check like you're gonna be off the left side if you have negative indexes, and then you'll be off the top column if you have a negative column index, and then you'll if you're off the right side you have one too large on your horizontal indexes, and if you're off the bottom you'll have one too large on your column index.
But yeah, you're
so
right.
You just check for all of that anyway. It doesn't have to be one smaller.
But you sort of treat it as
dead, if it were dead.
And it shouldn't ever change because it's sort of hard coded there. Right. So I mean, what I ended up with, I think I got all of the
2x2.
Yeah, I think I got. It's not all of the 2x2 combinations. It's the I guess it's like no live neighbors and one live neighbor, and so then this is like where I stopped.
Does it work for something that's rectangular?
No, let's find out.
Because I guess we need the 6.
Oops. Actually, you know, and I've got
2x4 maybe?
Did I change something here? Wrote that.
2x3
I've got this thing. Wait, live cell with 2 neighbors lives. I don't know if this one works or not. So the whole idea here is that let's see here, live cell with 2 neighbors lives. So here, after I get this one, I go 1 generation. This one, the first row stays alive because each one of these has 2 neighbors that lives, and then this one should stay alive also because it has 2 neighbors. So does that work? Oh, it doesn't. Why not? What does it get? Ooh. Oh, because I don't think I've implemented the functionality, the logic in compute next generation yet.
Okay. So what does this do?
No?
So far? Get next generation. What does that do?
Get next generation cell. If the cell is alive, number of live. Oh yeah, right. I don't have to implement. So it's like if the number of live neighbors is less than 2, it dies. If it's greater than 3, it dies.
So we don't have the stays alive yet.
Otherwise, yeah. So remind me. I can't remember the logic now. Let's go find the. What was it?
Is it 2 that it stays alive?
I think 2 is yeah. So if it's got buddies.
If it has 2, it stays alive.
Or 3.
Well, if it has 3 and it's dead,
Any live cell
alive.
with 2 or
And if it's
3.
alive, it stays alive.
No,
2 or 3 live
overcrowding.
neighbors.
I thought overcrowding was more
Than 3.
So 3.
Yeah,
live
so
more
it's
than
got
3?
2 or 3 live neighbors goes on to live. So I just
Okay.
need to implement that. So if it's greater than 3, else gather around. You can come closer if you want, or if you can see. Okay. I'm just glad to be doing this sitting down instead of standing up. It's an old man. What's up?
I just kind of had a quick question
Yeah.
about IntelliJ stuff.
Mhm.
I was encountering an issue where sometimes like it would fail to recognize that my test classes had any tests in them,
Oh, interesting.
and it seemed like I needed to like make it save in order to re-recognize that, because like I would comment something out and then uncomment it, and
We get
then
out of sync.
and then it would
Yeah.
get working again.
Huh.
So I was just wondering if you knew if there was any way to avoid that, or
No, I mean usually, well, from what I've seen, IntelliJ is pretty good at that. Every once, well, if I go and like we'll change the file outside of the IDE, sometimes it doesn't catch it and I'll have to synchronize. But usually when it happens all inside the IDE, it's pretty smart about that. So,
Did you get a message empty test suite?
yeah,
I would get that too sometimes.
yeah,
really,
yeah. Like I got that a lot, and
that does sound annoying. So yeah, I don't have any advice. Anybody else see that before?
I saw that once, and then after I did a Maven verify.
Okay, so then,
yeah.
I don't know.
Oh,
It's funky sometimes.
It's computers, darn it. Okay, so we run this again. Yay, it's happy.
So this is all if the cell is alive. Okay.
Well, yeah, so it's like if you counter one, right, and so like now I guess we need to say, we need to have so like we've implemented this one, and then this
3.
one, yeah, then we just implemented 3. So a dead cell with exactly 3 live neighbors becomes a live cell.
So we need the
So
else.
what are we doing?
need
We
the
wrote a
test.
test for it first.
Okay.
How could you possibly?
Well, should we see if that one passes now?
Well, this one did pass. That was the one we
Oh,
ran.
it did,
Actually,
okay.
but what we didn't do was we didn't go back and run all of them. Yay. Okay, so good. Got all that. I should probably commit.
So
I'm really
I have a
tired.
question
Oops.
about your assertions.
Yeah.
For each one, there's one assertion, and we're checking. It seems like we're checking on the one cell.
Yep.
That is of interest to us.
Mhm.
Would it ever be worth including additional assertions saying the other cells are unchanged, or is that unnecessary because of the logic in the program?
There's a school of thought that says that a unit test should only have one assertion in it, meaning that it should really only verify like one piece of logic, one path through your code under test. And so, and I think that helps you sort of break things into small chunks. And I like that because it's like I just want to think about this one scenario. Now, sometimes I think like my examples of like, oh, there's an error message. You want to check both that message was like my integration tests that say yes, this was written as standard error and the exit code was 1.
Right.
And there, I think it's okay because it's still the same scenario and there are multiple outputs of it. Here, I mean, definitely. I mean, both of these. So if we talk about like the given, when, then, these have the same given, right? So it's create this board that looks like that. As a matter of fact, I guess I don't have it. I guess there aren't so many that I would consider like trying to refactor this duplicate code into a method. If I think I had 3 of them, I would. But anyway, yeah. I need to commit something. What do I need to commit? I need to say implemented. What was that logic?
2 and 3 stay alive.
Yeah. Okay.
So now we have the same test with the same board as what you just had.
A dead cell with exactly 3 live neighbors. You're right. It becomes a live cell. So
Now we're gonna
now,
check the second row, second.
yeah. So now we say this is going to be dead cell with 3 live, and that's what it is, right? It's not exactly 3. Yeah, with 3 live neighbors comes alive. So we really don't care about that. What we really care about is row 1 car at 1 equal to star.
Yep.
So then this should fail. Yay. And now connect your next generation. Get next generation cell. If it's dead. Else. Assert cell equals dead cell. So I just add an assert to like, this is like not a test assert, this is assert in the production code, just sort of say, hey, I'm assuming that's a dead cell. Then if number of live neighbors equals 3 exactly, then return alive. Otherwise, it remains dead. Which we should probably have a test for. Nice. And so we want public void dead cell with 4 live neighbors. Stays dead. In order to get 4 live neighbors, you need a bigger board. It's got 5. No, there we go. So this one has 1, 2, 3, 4. So this is a game with rows, 2 rows, 3 columns. And there we want 1, 1 should equal 2 dead, right?
Yeah.
What?
Yeah.
Yeah.
So we didn't test that other.
It passes, is what we expect. Sorry, didn't test what?
Oh. Which one did we?
We tested this one.
We did test that one.
Right, 1, 1. So that's row 1.
We didn't test the one
column
above it. We wrote the
The,
code.
which one?
Line 139.
Dead cell with 3 live neighbors.
Oh yeah, yeah. This one passed. Yeah, we run them all. Yep, all 17 tests pass. Okay, so
What else?
Not the rectangular board, 2x3.
yep, yeah, this is a non-rectangular. What I don't have, and I don't have good data validation on. Oh, I added a row, to a 2x3, and it has 4 columns in it. We can add that, but that's not so interesting. It's like, what else do I need to test? So I think I've got all the small cases. Is it worth testing a big test? Let's commit these. Heated cell. Live cell.
So
What else do you
I
need to
think
test?
it is because, so not knowing anything else about the logic of how your rows get updated. So if you had a bigger test or a bigger board, if you're like updating one by one,
Uh-huh.
then it could, instead of updating everyone all at once, then it could change the results, right? In
Okay.
exactly the ways you mentioned earlier.
For
that we wouldn't
like
want.
if we had like an object that
Yeah, an object that just had a state, not like a.
Okay. Well, so let's write a test. Let's
Yeah,
see here.
so
What does
what-
that look like?
What kind of example would do that? How about star dot star, and then. Oh yeah, I guess.
Well,
Same board as this. That
Okay.
one above.
So like, well, okay.
Let's see what happens with a star dot star.
And then
Well,
which ones are interesting?
So what I want
Yeah.
is a case where that top middle one will become alive after it looks at itself, which will make something bad happen to something in the second row, something that shouldn't happen.
Okay.
So if you eliminate the bottom leftmost star and make that a dot, then the middle has 3 stars by it. So if that updates first and becomes a star,
Yes, then that
Gotcha.
then that
Other one
makes
will
the
become a
middle one
star.
below it have 3 stars surrounding it.
yes.
Okay, that's good. Okay,
Oh,
so
4 stars.
Oh,
You're absolutely right.
okay, so in this one, then this should remain dead. Right. So 1-1, which is this guy, should remain dead. No, this one should become alive.
yeah.
But it becomes alive if it has 4 neighbors.
No, it becomes alive if it has
Yes.
3 neighbors.
In
so
the
it should come
previous
alive.
generation, this is the thing, right? So it's like it's the snapshot. So it's like everybody, asks their neighbor, "What's your current, your current state?" And that determines the next state for everybody. So yeah, it shouldn't be.
Well, if you make
Uh,
that last one, the 1, 2,
Yeah.
be dead.
No, I think this is good.
Well, if you make that one dead, then that middle one will come alive. If the top. Oh, the top one will.
No, it only becomes alive if
Oh, yeah.
it's like this word.
Because like that, if you're going just sequentially and changing
Yeah.
them wrong, then the top middle will come alive, which will mean that the bottom.
I
will
got it
come alive.
wrong.
It should.
Expected star. Okay, why this one has? It only has 2.
Not just 3.
No, shoot. You're right. No, wait. 1-1. Why doesn't that come alive? Ooh, could that be a bug? Let's find out. Actually, you know what we should do? Stop. We should have another test. We should just say, I don't want to compute next generation yet. Assert that game dot get number of live. Okay, so 1-1 should have 3 live neighbors, right?
Yes.
Okay, do you start your numbering from 1 or from
0.
Okay.
So does that pass? Yes. So if it has 3 live neighbors, But any dead cell with exactly 3 live neighbors becomes a live cell. What am I doing wrong? Does it not think it's dead? Get press. Game of life. What is it? Get cell. That's what I want. So get cell. It's private, probably. Yeah. So go for testing. Get cell. 1 equal to a game of life dot dead cell. Am I going crazy? Ooh, okay, the game's afoot. Oh wait, which assertion failed?
The last one still.
Is it?
The third one.
Yes, it is. Okay,
Huh.
so compute next generation. Yeah,
Should
you
we
know what? You're
go-
right. No, it doesn't totally. I'm screwing it up because yeah. Because look.
Oh, is it being updated
Oh,
first?
Yeah.
So now it's being surrounded by 4?
Yeah.
By 4 live ones? So it's
Nice,
not gonna
okay.
become
Yep.
live? Okay.
Good test. Yeah, I totally messed that up. Okay, so
So we would
test
want
that.
Yeah.
Test that next generation is only based on previous generation. Nice, good catch. Okay.
So what do we need? We need 2 runs through your.
Nah, I think all we need to do is this.
Yeah. Just have another grid.
Equals new car. This dot row count. This dot column count. And then, oops, what does it look like? Up. That's what it doesn't look like. And then let's see here, each row we need to say new grid dot row equals new car array of this dot column count. And then this is new grid. And then this dot grid equals new grid. Yeah, there you go. That was a final. Not anymore, it's not. Nice. Okay. Let's try it again. Oh, I was not going to find it anymore.
Oh.
No, that's my fault. Because I changed the name of it. IntelliJ got confused. No, yes. Ding. Very nice. Yay. Okay. Yeah. Make sure that that earlier cells in the grid don't impact the next job. Gosh, cannot put words together. Cool.
I think that's all the logic we need, right?
Okay.
So then we just need to print it.
Yeah, let's do something fun. Yeah, so let's work on our main.
Would it be,
Yep.
would it be worth testing 2 generations? Because we've only gone from the initial to 1
Sure.
generation.
Okay, yeah, I like that. So then, I test multiple generations. Well, I don't need that word test.
So should we
Okay.
take that one?
Yeah, start
See
with
what
this
it should
one.
be at the next.
Well, we do that here, so like we gotta like advance it twice. Although
right.
just for the sake of sanity, we probably need to like. Okay, so we don't need that. So compute 1 generation. So like just say here that row 0 equal to, what is row 0 equal? That one has 3 dead neighbors, so it dies. The second one has 3 live neighbors, so it becomes alive. This has 1 live neighbor, and so it stays. Is that right?
So, 1.
A live cell with fewer than 2 dies. So this one dies. It should be a string. Right, do we believe that? Okay, and then
Second row.
this one has 1 live, so it dies. That one stays. It becomes
It
alive
becomes
because it's
alive.
got 3 neighbors.
That one dies.
That one dies. Okay. Not every cell truly lives. Okay.
By the 3rd generation, they're all gonna be dead.
Oh,
Oh no.
Oh no! Underpopulation. That's the game of life, kids. That's yeah. Okay, so then yeah, that's true, right? Because yeah, this guy only has 1 neighbor. Yeah, nobody has. Yep. Okay, and so then they die. Mew. Okay, cool. And everyone dies.
Well, it's a depressing game. You know, you
I-
can end with everybody dead, but you can't end with everybody alive.
But if you have the right startup, you can have
You can have endless like.
you can have an
pattern
endless
building.
pattern.
Yeah, actually, can you get to like?
Actually, you
Where
can get better
everybody
than endless
lives,
pattern. You
I
can
know.
get live cells shooting off
Oh, yeah,
into,
that's true.
into
These
infinity.
little, like,
That's just like
Fish things. They're like, oh.
yeah.
Yeah.
It just gets bigger and bigger, right? Population.
So,
Yeah, you've got an infinite board.
If you have an infinite, yeah, the board has to get bigger and bigger.
that'd be kind of interesting. Like, yeah, you get to a certain size and then it grows. It's the urban growth boundary, man. Anyway.
I've seen ones where like you've got 2 of these cannons that like shoot
Yeah.
Oh, yeah.
towards each
Yeah.
other and also catch.
Yeah. So let's make something
Well, I
pretty
don't know
now.
I don't know how they calculate that.
I was always so bad at
Let's.
geometry.
I don't even know if it's a matter of geometry.
Well, kind of is. It's thinking in pictures, understanding how things move in space. Just a child that got lost in the grocery store.
Okay, so a main method. What do we want for the main method? Because we need to seed it with something. Should we like have a file, a text file?
That'd be
Yeah.
easy.
Okay, so it's like read it from a text file and then do it from there. Okay, so let's just make it easy. Node if args.length equals 0, system.error.line. Missing file name, system.exit 0, exit 1, otherwise, file name equals that, and then game of life, game equals read game from file, new file name, for class, no. Really? You're so
First
smart
one.
about some things, and then it's just like, here's some random class from an internal API. Okay. And then let's have some fun. So then we'll say, oh, you know what we should also have is like the number of generations.
Yeah.
Yeah,
Or we
so
can just
like,
let it go until you.
yeah, you can control C it
until you
also. Let's
control
just do
C it or
that. Yeah.
something.
So then we'll say, yeah, sure, why not? While true. What?
Let it go.
Nothing wrong. It's like, okay. So then we'll say print game of life. There goes the game. And create method, blah, blah, blah. That'll print standard out. And then we'll say game.nextGeneration, compute next generation. And that's it. Oh, and we need to probably wait for a bit.
Yeah.
Thread.sleep. 1 second.
Sure.
The exception of the method signature because I'm lazy. Okay. Print game. So this is going to be Oh,
Is
I
there an
can't
easy
do
way
it
to
then.
clear the screen?
Probably.
Just keep printing.
Well, we'll have a couple spaces in between it. So we'll see. And we care which generation it is? No, I guess not. So let's see here.
Yeah, you can print just right above it. Like
Yeah,
generation.
or just whatever. So let's see here. Game.get cell get row, but I don't know how many rows it has. I need to find out how many rows it has apparently.
I guess you can format the file.
For int row. I haven't even gotten there yet.
Yeah.
Game.get row count. Row plus plus. Getter, is there already a row count? Oh, I'm so smart. Okay. What was I complaining about?
You need
Oh,
less than.
row equals 0. Row is less than game.row count. System.out.print line. Game.get row, row index row, and then once done all that, system.out.print line, print empty row, and then read it from the file. Oh, there's a way to do this nice now. What do I say? Is it file start? Read lines. Oh, baby. Oh, it's so much easier than it used to be. File.getPath. Oh, yeah. No, that's not right. File.toPath.
What is that?
The path is like in the new, IO API,
Mhm.
and it's just another way of representing. Is it just files, or I think there are other abstractions that I can handle too, like URLs or something? It's paths from. I can't remember. It's probably got some exception it's not happy about. Yeah. Oops. Add exception. Add exception. And this is lines. Put to a variable. What? No. Lines. And let's see here. The so int row count equals integer.parsent line 0. Oh, get 0. And then row and then column count is line 1. And then then we need to create the game of life. Game equals new game of life with the row count and the column count. Make sure I got that right. Yes, I did. And then for int row equals 0 while row is less than row count.
Row count?
Yeah. Row plus plus, and then game.add row lines 2 plus row, right? The first two lines.
The first two are just the sort of
Yeah,
how many rows and how many columns. you have.
exactly.
Okay.
Does that seem right? Return game.
We will find out if it's do something weird.
You know what? I lied. I don't want to do this after all. Or rather, I want to do. I want to do this. I don't. This API is neat, but actually, can I read all lines? Oh, is there like a? I can't test this because I don't have to create the file. I want to write a unit test where I can just, make sure I'm parsing everything correctly.
Mhm.
So I'm not doing a test driven, and I ought to be. So can parse game of life file, text file, a text format. That is what it is. oops, void there. And so then string builder SB equals new string builder. So the first line is going to be, we'll just have like a 2 rows and oh, and you know what? I don't want. By 3 columns, and then SB dot oops dot append, and here I just want it star dot star. Yeah, it's row 1 SB dot append, row 2 dot star dot, and I'm going to want these to be variables. Row 0. I want this to be row 1. Row 1. Then I want game of life. Game equals game of life dot. What do I call it? Read. I don't have one yet. Okay. I want parse text format of SB new string reader.
What's a string reader?
It gives you the reader class around a string, so I can use like a reader. The file reader is a reader, but this is when I read the source is a string. It's not a yeah. And ultimately, this is what I want to make it testable. I do it this, and then
You can't just parse the string because the parse text format is going to take a reader.
yes, yeah, right, yeah. So this is just going to be a reader. It's going to be a reader, and then we want to assert that game dot. Whoa! What's it doing? Stop! I can't see you anymore. There we go. Get row 0 equal to rows robot. That. And row 1 equals to row 1. What is this saying? May produce a null pointer exception. You may be right. Yeah. So this is, oh, why is it public? It's public. It's just used for testing. Same thing with this thing. Okay. So then, right, because we try to run this, then it's going to blow up spectacularly. Because it's not implemented, null pointer exception. You are correct. And so then this thing, okay, so now I want, night. Where'd all my logic go? Here we go. Now, I wonder if there's a way to say, read all lines from a Java read all lines file from a path. No, it doesn't look like there's a way. I was wondering if there was a way to take a reader and have it read all lines. I'd be surprised. Read all lines. Yeah, it doesn't like. Yeah, okay, that gives you a new buffered reader, which is the same thing there. Okay, no big deal. I can just do it the old school way.
Read like one line at a time. Is that...
Yeah. So I should just. Buffered reader BR equals new buffered. So buffered reader gives you the readline method,
Okay.
and then
Is there a difference between using a buffered reader and like a scanner?
I'm not familiar with scanner. I never. That's not something I used. Oops. buffered reader dot read line. And this is like super error prone, right? It doesn't do a very good job of handling bad input, but and then read line. Give that a try. Oops, unreachable statement. Yep. Oh, that's not what I want. Yes. Again. Oops, no pointer exception. Add row. So that is null. What did I get wrong?
Wait,
I bet I
what
forgot
did
some
you
new
do?
lines. I bet I forgot some new lines. Yeah, that's what I did. Yep. Forgot new lines. Yay. Okay. So now, what is it complaining about? Oh, yeah. Okay, so there we go. Thank you. Much better. Yeah, but it won't be as pretty. Not that it's very pretty now. Okay. Make sure that works. Yes. And now, the parse file just becomes return parse text format for new file reader file. Okay, so now let's create ourselves a file.
Yeah, I don't know what's going to produce an interesting pattern.
Oh, we can find out. CD back life.
I'm sure we can search for something.
Maven clean. Do I need to verify? No, let's make the package. Let's see here. This is like just like game.txt. Okay, so like let's do just like 5 by 5. Oops. Insert 5 by 5, and then like let's have some dead stuff, and then let's have like something live there, and then something
We
like
want some places where they are surrounded by 3s, right? Because those will all just die.
Oh, you're right. We need 3. Yeah. Okay. So then
There's nothing wrong with them dying, but second generation.
Well, so then like, and then we need a 5th one. All right. That's 1, 2, 3, 4.
Sure. Well, let's see what.
Yeah. Let's see. Actually, it probably like dies in 2 generations.
Yeah.
So you know what we should do? We should have an exit when it's dead.
Yeah. Otherwise, it will just keep printing.
Right. That'll be
dead-
super
dead
annoying.
ones.
Yeah. So yeah, I was running until it dies. That's nice. And so then while game.
But do you have an easy way of checking when they're all dead?
We'll have to add one. While game has live cells. Game. I can write a test for that. Get tired. I don't care. Okay, so then for int row equals 0 while row is less than game dot get number of rows, get row count, row plus plus, and then string row equals game dot get row, and then oops, what does it look like? String. I forget it. If index of live cell game life dot alive cell if anything is alive, it doesn't equal -1, then return true. All right.
Yeah.
And then, let's just say row contains. That's hard to read. It's hard for me to read.
Yeah.
If row contains a live cell. There we go. Otherwise, everything's dead. Return false. And then let's just. I'm feeling guilty now. I don't have a test. One live cell means game is alive. Let's just take one of these. Ooh. Assert that game. Actually, a game of life is game alive. Game has live cells. Oh wow, it's late. Game has live cells. Game equal to true. Does that work? And then
Right.
yay, and then probably is
Test it
no live cells. No, no live cells. No live cells. Yeah. Equal to false. Wasn't test driven because it was already implemented. Well, it works. Okay. Okay. So now let's do this again. Package. Java-dar target game of life .jar is in file name game.txt, and they all die. That's cool.
Yeah.
Okay, let's get something a little bit more interesting now.
Find anything that was.
I did. I found the smallest interesting pattern in game.
Okay.
So like, okay, cool.
So is that a 3x3?
Yeah, although you'd want the board to be bigger to.
Oh, to see the other
grow.
stuff. Okay.
Okay, so let's do a 5x5, and then what is that? There's like 3. Wait a second.
So if you're looking at just
So,
the middle one.
Star dot, and then
Dot.
Star.
and then star star.
Yeah.
And then some nodes there. Cool. And then dash jar. Neat.
Yeah. Is it migrating off to the left?
And there they go.
It's one
Oh,
of the ones that just
Yeah.
goes all over the place.
I see.
Yeah.
Some things if you have a really big board.
If we have a really big board, it
Oh,
might
yeah.
not die. Yeah.
Right.
That's
Okay,
really
that's neat.
Yeah.
Get add game.txt. Okay, just an IntelliJ. Okay. Sweet. That's pretty cool. Okay. So add a command line tool for displaying the evolution of a game of life. Read as specified, subscribed in a text file. Fun. And next week we'll do that in GWT. Pretty pictures.
Yeah.
That's what computers are for.
Yeah, that's why I stuck around. I just wanted to see it move.
Yeah, right? Yeah. Okay,
It
awesome.
wouldn't be hard to do it in GWT. I guess not.
Oh,
right?
I
You just
plugged
have
that probably totally messed up
box
Camtasia.
that updates itself.